In this video, you will hear about what CATLOC is, why it's such a good idea to perform cost analysis, and how to apply such techniques in reality. First of all, CATLOC is a cost analysis tool. So, to understand what CATLOC is, we need to start with looking at what we mean by cost analysis. The main ideology behind lifecycle management analytics is to understand the future impact of current decisions. And this applies, of course, to cost analysis as well, since that's a central part of the LCM work. In any situation, whether it's about design, acquisitions, contracts, or any other step in the project life cycle, you will face different type of decision points. And I guess no one would argue against the fact that the best way to tackle any decision making is knowledge. If we can understand the outcome of all possible alternatives, the choice of path will not only be easier, but also better in the long run. But why is it so important to understand the cost implications? Well, in any project, large or small, one of the key requirements is funding. Who hasn't been told we must keep within budget? And surprisingly often, this kind of requirement tends to be forgotten once a project is up and running. During the early stages, cost awareness is typically high since budget constraints and total costs are on top of people's mind. However, as projects are being rolled out, this attention easily drops when people start focusing on tracking things like system performance instead. Doing so might make people forget about future implications, which could cause the costs to skyrocket, risking budget and success of the entire project. When talking about cost analysis, we hear buzzwords like life cycle cost, total cost of ownership, or asset management. But what it all comes down to is to understand the total cost picture. We can't just focus on the costs we see up front. These are the ones that are above the surface, easy to spot. Actually, a majority of the expenses will occur at a later point in time, somewhere in the future. And these costs are not obvious to spot in advance, so they are hidden under the surface. So, the decisions you make today will echo for, well, maybe not eternity, but definitely for the rest of the life cycle of your project. Now, let's take a look at how CATLOG works and how to use it. To understand the basics, we'll start by taking a closer look at the inputs. The CATLOG approach can be split up in three important concepts: the cost model, the elements, and the data. Forming a cost model is an important part when you want to reap the benefits and power of cost analysis. So, the cost model defines all the cost items. It also describes how these costs are structured, aggregated, and calculated. Now, let's take a simple example where we have a top node representing the full LCC, lifecycle cost value. Now, this top node can be split up into a set of sub-costs. For example, costs for design, support, operations, and termination. In other words, the sum of these sub-costs forms the value of the overlying node. And this relationship between costs and sub-costs can also be represented as a structure with parent-child relationships. Again, the overlying cost is the sum of its children. Important to know is that the cost model in CATLOG is truly 100% flexible, and you can build any structure with any nodes that you want. CATLOG can also handle any depth of the cost model. So continuing this example, we could create another set of sub-costs, splitting up the design costs into R&D, software, documentations, and training costs. Again, the sum of the sub-costs forms the value of the overlying node. This next level can of course also be formed as an hierarchical structure showing the relationship between the cost items. Let's take a look at the breakdown of the support costs as well. So overlying costs are calculated as summations of its children, but the leaves in the cost model tree are different. The value of those costs can either be defined as an actual number or can be calculated from a formula. For example, the cost of acquiring spares can be defined as the quantity multiplied with the price for each individual spare part. Another example could be the cost for maintenance resources, which, for example, may be calculated as the utilization times the usage cost per hour. The second concept of the input is the elements. This is a way to describe all the individual objects that forms our scenario. If we take a closer look at what we need to calculate the cost of spare parts, we realize that we need to know what spare parts we are talking about and probably also at what location these parts are being stored. So, what we do is to define elements for each part as well as for each location. Once we have the elements, we are ready for the last step of the input, which is to give the actual data, the numbers for each element. Here we wanted the quantity per spare part and location, as well as the price per spare part. Note that the price probably don't differ per location, it only depends on the part. And with this data, we can now calculate the actual cost. For example, the spares investment of disks at site A will be 3,600. And for filters at site B, the cost will be 3,000. There are some different ways of filling out the inputs to CATLOC. Of course, we can start from scratch and go for the full details, building any model with any formulas and give all the data. In other words, the CATLOC model is truly 100% flexible. Another approach is to start simple with cost estimates on a high level, and as more and more data becomes available, we can fill out the details. A third way is to use any of the predefined templates that comes with the installation of CATLOC. This will give you a quick start. Even though these templates doesn't contain any elements or data, they still give you a great starting point with a fully defined cost model. And the last option is to benefit from existing models used for other analytical LCM applications, like the ones in Opus 10 or Simlox. Actually, by integrating CATLOC with results from the Opus Suite, you'll get a complete model setup in just seconds. But this is not just a mirror of what you get from Opus 10. These CATLOC models also come with full flexibility in terms of data updates and additions. Now let's move to the really fun part, the outcome of the cost analysis. To explain the benefits of performing these analyses, we'll split things up in 3 steps. The first one is to perform the calculation. This will give us the total cost value given the current input data and showing the actual number in monetary terms. The second one is control. With a flexible cost model like the one that CATLOC offers, we can get an understanding of what is actually driving the LCC value that we just calculated. By understanding what the main cost contributors are, when they occur, and what elements that are driving them, we'll be able to adjust reality where it gives the most impact on future costs. The third part here is to establish or assess the results by addressing future risks through different what-if scenarios or by using the extensive built-in sensitivity analysis feature of CATLOC. With such an approach, we can test the robustness of the model and the results it produces. Let's take a quick example. As I just said, the calculate part will give us the total cost value. Here we look at the lifecycle cost of some program, which give us the total cost of 10,000. This number is of course highly important itself, but with a flexible model like the one CATLOC offers, there's so much knowledge to find if we just dig a bit deeper. Now if we expand the cost model, we'll find the first level of the breakdown, and the corresponding numbers can be seen in the results. And if we further expand the design and support costs, we'll find yet another level of costs, and again these are displayed in the results. As you see, we can examine the entire cost breakdown tree in just a few clicks and get a great overview of how the costs are distributed. Results can be displayed as the bar graphs you see here, but they can also be presented as pie charts, in percentage values, or as pivot tables. This is not all. Let's take a closer look at, for example, the cost for spares investment. If you remember the different parts of the input, we also created something called modeling elements. With this approach, we can now split the costs per type of spare part. Or we can split the cost per geographical location. Or even both at the same time. And the power of this is the capability of understanding what's really driving the costs in order to find areas where we should improve to really make an impact on the total cost. Last step is about evaluating risks and assess the robustness of the results. Let's take two quick examples. First, what's the impact on the total life cycle cost if the spare part cost increases with 50%? Well, with a built-in sensitivity analysis, we get a direct answer and the results shows an additional 3%. Second example, what if the repair costs are under the influence of some general inflation and would increase by, let's say, 7% per year? Well, with CATLOC, it's easy to just update the formula for the repair cost, resave the input with a new name, and compare the results from these two alternative cases. And by the way, this approach is actually one of the greatest benefits with CATLOC, because above all, LCC is a tool for assessing cost implications of various decisions. And in CATLOC, you easily make any changes to your input, save it as a separate file, and compare the results in an extremely flexible way to understand all the cost differences between your alternatives. All right, let's quickly look at some other benefits that you'll get when working with CATLOC. It's possible to do powerful KPI estimations for things like cost per flight hour or cost per kilometer. CATLOC does not only handle costs, but can also be used for analyzing things like revenue versus expense or any other budget or economic forecasting work. With CATLOC, it's possible to work with an evolving LCC model as your project moves along different phases in the life cycle and more data becomes available. By comparing multiple scenarios side by side, you can easily visualize the cost effects from alternative solutions. Once you have a cost model set up, you just need a few clicks to reuse that model for another project. And compared to a complicated spreadsheet, handing over a CATLOC model to a colleague is just so much less pain. CATLOC has been used and proven valuable in numerous large-scale projects all around the world. A part of the success is that people continuously get training, support, and new releases. At last, remember that the LCC typically isn't something that is set in stone. You own a bigger part of it than you think, and through a foresight and a predictive approach, you may control future costs by current decisions. If you want to know more, visit our website or contact your nearest Systicom branch or Opus Suite representative for a live demo or further information. Thanks for watching.